VU2EVQ design HF linear amplifier has a nominal power rating of 100 watts and is meant mainly for 40 meter, though it can give same output on lower bands and a lower output on 20 meter. But you will have to change the low pass filter circuit for each band. It is not recommended for higher bands. Earlier, the full amplifier was available from VU2EVQ. Recently, I bought a PCB from VU2EVQ with all the SMD components pre-mounted and homebrewed the rest of it successfully. All components are locally available. Toroids can be purchased from VU2PTI and the transformers hand-wound by us. Contact information of VU2EVQ and VU2PTI are available from qrset.com. Good support is available from VU2EVQ in case you have difficulty in homebrewing, which I found very helpful. VU2TDD is another person well versed in the assembly of VU2EVQ linear amplifier from whom I could get support, in addition to a lot of support from many more local amateur radio friends on the air. This is the printed circuit board which I purchased from VU2EVQ. It is meant mainly for beginners who want to have a 100 watt signal on 40 meter using the popular Bitex radios. Bitex radios have about 10 watt output on 40 meter. We need only about 5 watt input drive for this linear amplifier, which will work on 13.8 volts, the standard voltage of power supplies and battery. Though power output can be higher at slightly higher input voltages, that is not recommended. A good heatsink the size of the PCB is needed to prevent overheating of the final IRFP150 MOSFETs. This is the heatsink which I used, meant for audio amplifiers. I have used a couple of them in the RF linear amplifier obtained from local market. The final power MOSFETs were screwed onto these heatsinks. An insulator silicone sheet and heatsink compound were used for that. The silicone sheet electrically insulates the MOSFET from the heatsink while permitting heat transfer. Here you can see the final MOSFETs and the silicone insulator sheets. Though both of them are kept on same heatsink for the initial demo, they were mounted on two heatsinks separately. Heatsink compound which came in a syringe, and it was easy to use by spreading over the MOSFET and insulator sheet. Voltage regulator ICs 7805 and 7812 with heatsinks are shown here. 7805 supplies the regulator bias voltage to the final MOSFETs. 7812 provides the regulated supply to the transmit-receive DP/DT relay. Power supply to the final MOSFETs is directly from the power supply through an RF choke and RF output transformer. Here are the 6 ampere reverse polarity protection diodes, relays and 2 kV ceramic capacitors. You can see 2 of each, as my initial plan was to homebrew 2 boards and combine the outputs, which I have deferred for time being. Please note that 6 ampere diode is not connected in series with the power supply but to the ground. Hence, power supply should have protection to prevent high current damage in case of accidental reverse polarity usage. That is, the fuse in the power supply should blow off in case of inadvertent connection in reverse polarity. The diode is meant to protect the linear amplifier and not the power supply. I had inadvertently purchased through the hole components of some of the SMD components which were already mounted on the PCB, like the transistors and diodes shown here. Thick resistors are for the input attenuator. Similar ones are needed for the feedback circuit at the output of power MOSFETs as well, which I had not purchased initially. Usual type of enameled copper wire is used for winding RF choke and low pass filter inductor coils. White wire is the winding wire meant for submersible pumps to be used for winding transformers. The coating of these wires are less likely to be damaged while threading through the binocular toroids of input and output transformers. A good 12-volt DC fan has to be running directly over the final MOSFETs for adequate cooling. VU3GZR has used an additional fan which starts running when the temperature of the MOSFET reaches a threshold value. He is using a temperature probe on the MOSFET with a circuit board and relay for that. I had also purchased that type of board later and demonstrated its working some time back. I have not added it to my linear amplifier. This is a BN43202 binocular toroid. You can see two holes. That is the binocular toroid which I am going to use for winding the input transformer of VU2EVQ linear amplifier. This is my very small binocular toroid. Incidentally, this is another device which I bought recently for helping me to solder. That is, the crocodile clips can hold materials for soldering, and if I need, I have a magnifying glass also here. This is number 25 copper wire which is to be used for submersible motor winding, and I need 25 centimeter in one piece, another 10 centimeter piece, and it is fairly easy to take measurements here. This should be 25 centimeters. I need another piece which is 10 centimeter long. I can measure it out here. Now I have to wind it through this. If I take one part through the other end and put it like this, that is one turn of the binocular core, and it has to be tight, but it should not injure the So I have completed 2 turns. Three turns are completed. Now I need only a single turn for the secondary winding. So that should complete the secondary winding also. Now I have to check the continuity. I am checking the continuity of one side. There is continuity. On the other side also I have to check continuity to make sure that the insulation has been removed properly. That's also continuous. Then the next is checking between primary and secondary to see that there is no short. There is no continuity. So that means I have not damaged the insulation in the process of winding this transformer. 30 centimeters of 18 gauge enamel copper wire and this FT5043 toroid. This is a small toroid. I am going to wind it. It will be a little difficult because this is a stiffer wire compared to the wire which I used yesterday. Because I am trying to wind it, most likely I'll end up damaging the insulation as well. Anyway, I got one turn in. Now I'll see whether I can get the second turn in also. I think I have scratched the insulation a little bit here. Coils for L2 and L3, that is the inductors in low pass filter, were wound on toroids and mounted along with the ceramic capacitors for the low pass filter. Instead of two RF 1000 toroids in the VU2EVQ linear amplifier design, I am using a single BN437051, which is a binocular toroid bought from VU2 PTI, as RF 1000 was not available. Primary winding of this transformer is being made by copper tubes used in refrigerators. I got it from a refrigerator spare parts shop in the city. Two pieces just enough to fit inside the two holes of BN437051 forms the primary winding. Took the toroid to the shop and got exact size of copper tube which goes inside, and got it cut exactly as well from there. One end of each copper pipe is connected to the drain of each IRFP 150 MOSFETs. The other ends of the copper tubes are shorted to form the central tap of the primary winding. They are connected to the bar on the PCB, to which RF choke is also connected. In effect, that will go to the positive power supply line through the RF choke. 18 SWG copper wire was used for the connections. Had a very tough time soldering them to the copper pipe. Needed 100 watt good quality soldering iron and a lot of effort. I went through several cycles of soldering as the solder joints on the copper pipes would not hold. Scraping inner side of copper tubes in hope of making soldering easier. Applying solder lead to the copper tube as the first step. Repeating process on opposite side after fixing one side. Soldering the second wire connection. Applying lead to the copper tube on opposite side. Soldering of primary winding completed. Central tap is the shorted wire shown initially for connecting to the metal bar beneath. Other side goes to the drains of IRFP 150 MOSFETs. 2200 PF 2 kV capacitor is to be connected across. Here is the full view of soldering on copper tubes on both sides. SWG wire for submersible motor. Took 35 cm for winding secondary. Secondary winding is 3 turns of 19 SWG insulated copper wire used for submersible pumps. One end of the secondary winding goes to the low pass filter and the other end goes to the ground bar just beyond the bar on which the central tap of the primary winding is connected. Checking placement on PCB. It is slightly bigger than the space available. Finally, establishing the continuity between two ends of the secondary and lack of continuity or shorting with primary. Sometimes it so happens that part of the insulation gets scraped off. Look out for the next exciting steps in homebrewing of VU2EVQ HF linear amplifier.